Hello and welcome back to Mr. Powers Teaches Stats. Let me see. We are in section 1.2, and so today we are talking about types of data. Know and understand the meanings of the terms statistics and parameter. Describe different data types. The type of data is one of the key factors that determine the statistical methods used in the analysis of data. All right. So, if we're learning a word, it's probably important. What's a parameter? A numerical measurement describing some characteristic of a population. Parameter. What's a statistic? A numerical measurement describing some characteristic of a sample. Okay, so what's the difference there? One, we're talking about a population. The other, we're talking about a sample. Okay, one has to do with the population. Parameters go with population. Statistics go with samples. Quantitative data. Well, when talking about quantitative, you want to think quantity. You're thinking numbers. It even says right up there, or numerical data. All right. We got quantitative, numerical. That's how they go. Data that can be represented with numbers consists of numbers representing counts or measurements, the weights of supermodels or lack thereof, and the ages of respondents. Okay. These are numbers, right? They can be ordered also. Let's see here. Categorical data, on the other hand, is going to be everything else. Stuff that's not able to be represented with numbers. Lots of times we'll say qualitative. I don't see this one as much, but there's attribute. But usually it'll be categorical or qualitative data. Consists of names or labels, not numbers that represent counts or measurements. Everything else. So like gender, could be male or female of professional athletes. Shirt numbers on professional athletes. Which numbers assigned to you. What's your favorite color? Red, blue, green, right? Those kinds of things are categorical or qualitative. Stick shift versus an automatic transmission in a car. There's some more examples. So working with qualitative data. Okay, so there are different types of qualitative data. We have discrete data and we have continuous. Now, discrete is almost always going to be anything that's a counting number, counts, okay? So like how many? Like how many dogs do you have? Well, you have one dog, you have two dogs, you have three dogs. Can you have 2.5 dogs, 2.5, 2.3 dogs? No, you cannot. You can't have in between a certain interval of dogs, and that being whole dogs. Those kinds of variables or qualitative data are discrete. They are discrete. As opposed to being able to go in between any interval you want, like your height, your weight, your age. Those are continuous. You can't go from 2 years to 3 years without first going to 2.5 years, right? You got to hit everything in between. That's continuous. Discrete data. Result when the data values are quantitative and the number of values is finite or countable. So here's another example. The number of tosses of a coin before getting tails. Can't have half a toss or a third of a toss, right? You got just whole tosses. Those are discrete. Continuous data result from infinitely many possible quantitative values where the collection of values is not countable. Example, the lengths of distances from 0 centimeters to 12 centimeters. You can get anything in between. You can get 6 centimeters, 6.7 centimeters, 6.78 centimeters, whatever. All right. Levels of measurement. Another way of classifying data is to use 4 levels of measurement. We got nominal, ordinal, interval, and ratio. So what's the nominal? Nominal level of measurement is characterized by data that consists of names, labels, or categories only. The data cannot be arranged in some order, so such as low to high. So like shirt sizes, those are categorical, but they're not nominal because could be ordered from smallest to biggest. Survey responses of yes, no, and undecided, that could be nominal. Colors, if you really wanted to, you could probably order the colors. Some of this stuff is a little fuzzy. Anyway, ordinal level of measurement involves data that can be arranged in some order, but differences obtained by subtraction between data values either cannot be determined or are meaningless. So we got grades. There's another example of ordinal. And the example I gave before for ordinal shirt sizes, that would be ordinal. Interval level of measurement involves data that can be arranged in order, and the differences between data values can be found and are meaningful. However, there is no natural zero starting point at which none of the quantity is present. So for examples, years 1000, 2000, 1776, and 1492. Okay, so differences matter. That's going to be your key takeaway when we're talking about interval levels of measurement, is that the differences between data values are meaningful. Because the difference between the year 1000 and 2000 is 1,000. There's 1,000 years. It means something, right? You can do that. Then you got your ratio level. It's going to be very much like your interval level, but this time instead of getting differences, we're going to get ratios. So data can be arranged in order. Differences can be found and are meaningful. There is a natural zero starting point where zero indicates that none of the quantity is present. Differences and ratios are both meaningful in this case. So there's that, differences and ratios, and this time there is a zero. Let me see here. I'm having trouble drawing straight lines. Let's see. And there is a natural zero. Okay. So class times of 50 minutes and 100 minutes. So class times, you can't have a negative class time, but you can start at 0 minutes and then go up from there. All right. So to summarize our levels of measurement, and all these are pretty much categorical. We have nominal, which is just categories, can't order them. Ordinal, okay, categories we can order, but differences don't mean anything. You can't do differences between them. Interval, okay, they're ordered now. They're categorical. Well, actually, they might not be categorical anymore, right? I'm sorry. Sorry, they're not like intervals. We have a natural zero, no natural 0 point, but probably using numbers because differences matter now. And then ratio, differences and a natural 0 point. And we have ratios. Ratios matter. Okay. Moving on. We got big data. What's big data? Big data refers to data sets so large and so complex that their analysis is beyond the capabilities of traditional software tools. Analysis of big data may require software simultaneously running in parallel on many different computers. Data science involves applications of statistics, computer science, and software engineering, along with some other relevant fields such as sociology or finance. Sorry, getting a little something in my throat. All right, missing data. A data value is missing completely at random if the likelihood of its being missing is independent of its value or any of the other values in the data set. That is, any data value that is just as likely to be missing as any other data value. Over here, a data value is missing or not at random if the missing value is related to the reason that it is missing. Missing. So we got missing completely at random, missing not at random. So correcting for missing data. Delete cases. So one very common method for dealing with missing data is to delete all subjects having any missing values. And then we could impute missing values. We impute missing data values when we substitute values for them. Okay? And that is the end and total of section 1.2. I hope you guys found that useful. And until next time, have fun doing math.